Alrighty, y'all, so I'm gonna go to my screen so we can start our notes up. Alright, so we're gonna pick up and finish out 8.5 and then knock out 8.6, and that'll be all the material for this third test. So here we go with 8.5, and it's still dealing with the rational functions.
Can I mute my phone?
All right, let me get another one in. All right. All right, so on this problem, I'm going to list the asymptotes. Of the function. And then I'm going to graph the function.
And he said, "Oh, so you didn't contact me yesterday, but send me a text this morning."
All right, so let me do something real quick,
y'all.
y'all.
Yesterday, come able to be here this afternoon. I said, he's like, just trying to make sure the details right. So he was trying to make it seem like I was doing a no call, no show.
All right, that'll be better. So if y'all want to talk, y'all actually have to press y'all's mics, okay? All right, so we're going to list the asymptotes of the function and then graph this function. So they're giving us f of x equals 5 over x squared minus 4. So first thing I'm going to do is find my vertical asymptotes, and I'm just going to call that a VA to shorthand that. So for my vertical asymptote, remember I got to take the bottom of my fraction and set that equal to 0. So I'm going to set x squared minus 4 equal to 0. And then, y'all, I'm actually going to use the quad to solve that. So if you use the quad, A will be 1, B will be 0 because you don't have the x term in here, and then C will be the number, which is the negative 4. All right, so let me pull my calculator over here. I'm gonna go program, go down to quad. And then enter to start it. So I had A was 1, B was 0, and C was negative 4. So when I put that in, that gives me x equals 2 and x equals a negative 2. So those are my vertical asymptotes. And since I have no factors on top that cancel out either one of these asymptotes, I can keep both of these answers. Okay.
Okay, so can you explain to me again why negative 4 and 0 is switched?
Okay, because when you do a quadratic equation, you're always in the form of ax squared plus bx plus c equals 0. So notice in our problem, I had an a here, which was 1, right? But if you notice, I don't have the x term in the middle. So since I don't have an x term, that's like my equation is 1x squared plus 0 x's, and then my c was the negative 4, all equal to 0.
Oh, okay.
So
okay,
since
gotcha.
there's not an x with my 4, I can't use it as my b, and it's got to be my c.
Okay.
Okay. All righty. And then you always check the top to see if there's any factors that match, but I don't even have a variable on top of this, so there's no way it's going to cancel out either of my vertical asymptotes. So now that I got my verticals, I would find my horizontal asymptotes. So my horizontal asymptotes, I got to compare the top degree with the bottom degree. So there's no variable on top of my fraction, so the top degree is a 0. On the bottom, I do have a variable, and it looks like it's got an exponent 2, so the bottom degree would be the 2. So I'm going to put less than, greater than, or equals. So since my top degree is less than 2, it would be less than, which means the bottom degree is bigger than the top degree. And anytime the bottom was a higher degree than the top, your asymptote for horizontal would be y equals 0. So remember, on the horizontal, we had 3 cases. They could either be greater than the top, less than the top, or equal to the top. All right, and then that wanted me to graph that, right? So now I'm going to graph it. So I'm going to bring out some graph paper in a second. But I want to tell you, there might be more information when I graph it that'll help me. Things such as a y-intercept. That'll help me graph it. And then I'm going to see if I got any x-intercepts. So to find the y-intercept of a function, you want to find what f of 0 equals. So what I would do is take my equation. I got a 5 on top. On bottom where I got the x, I'm going to replace that with a 0. So I get 0 squared minus 4, which that'll give me what, 5. Let's see, 0 squared is 0. 0 minus 4 gives me a negative 4. So that would equal just a negative 5/4. So since that's your y-intercept, remember that point will be 0, negative 5/4. So that might be another point that would help me when I start graphing that. Also at x-intercepts. So to find x-intercepts, you would set the top of the fraction equal to 0. So the top of my fraction is a 5. So I would try to set that 5 equal to 0. But y'all, since this doesn't have a variable, there's no way to solve it. And that's a false statement. So since there's no variable on the top, this one has no x-intercepts. So you got to have a variable in the numerator for this thing to have an x-intercept. All right, so let's see if that gives us enough to actually draw this graph. So I'm going to move this to the side and bring me some graph paper down. Whoops. Bring me some graph paper down here. All right, so let me draw a graph. And this is always the fun part, drawing the graph. And I'll go out about 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll go negative 10. All right, negative 10 left. And then 10 up. So that's my y-axis, and that's my x-axis. Okay, so the first thing I'm going to draw are those vertical asymptotes, because my graph cannot cross over those vertical asymptotes. So on our paper, we had vertical asymptotes at 2 and negative 2. So we're going to draw imaginary vertical lines at the x equals 2. And at x equals a negative 2. So the graph cannot cross over these lines. It'll try to get up to it, but it's just going to keep going one way or the other along these lines. It cannot cross over it. All right. Horizontal asymptotes that we found, the y equals 0. that just tells us what's going to happen once the graph gets way out here on these x's in the negative direction and the positive direction. So I'm not going to worry about that yet. But notice we did find the y-intercept we said was at 0, -5/4. So y'all, -5/4 is about a -1 1/4. So let me come down to my y-axis. There's -1. So -1 1/4 will be right past that -1 there. Now, we also said there were no x-intercepts. That means our graph cannot touch the x-axis. All right, y'all, there's only one way for this to go. This side can't go up because it can't touch the x-axis. So that means this side has to come down. Starting at this point, it cannot cross the x-axis. So this one has no choice but to come down. So now we need to figure out what's happening over here. And this is where you might need another point to try. So we need to know if the graph is going to be up here in the positives or is it going to be down here in the negatives, okay? So what I might do, if you notice over here, I got a 10. So I'm going to come in and find f of 10 just to see if I'm positive or negative. So to find f of 10, I'm going to put a 10 in for that x squared there. So I got 5 over 10 squared minus 4. So that's going to give me a 5 on top. 10 squared will be 100 minus my 4. And that's going to give me 5 over what? 96. Now, I don't care about the number. I just wanted to see if it was positive or negative. So since it's positive, that means on this side, since this line's coming down here, it's got to be up on this positive side. So it's going to come down. So notice it's sort of opposite of this one. And then it's going to try to get to the 0 over time. So that's where that horizontal asymptote's coming in. It's going to try to get to 0, but remember, it never can get there. All right, now if that would have been a negative 5 over 96, my line would have came down here and would have headed down just like this one. All right, y'all, so now if you wanted to do the same thing on this side to check and see if it's going to be positive or negative, you can find what f of a -10 is. So let me come in and find f of -10. That'll be 5 over -10 squared minus 4. So you get a 5 on top. Now remember, anytime you square a negative, it's going to become a positive. So this is 100 minus 4 again, which once again will give me a 5 over 96. So I didn't care about the number. I just wanted to see whether it was positive or negative. Since it's positive, the graph is going to be up here in opposite of this one. So it's going to come down from that vertical asymptote. And then it's going to curve around and try to get down to that horizontal x-axis, because that was y equals 0. But remember, it never can quite get to the 0. So I'm going to show y'all how to graph this on your calculator. So let me turn it on. Clear that. I'm going to go to my y equals. Clear that. So on top you had a 5. So push 5 and then divide. Since you got more than one part on the bottom, it's got to be in parentheses. And then we had an x squared and then minus 4, close parentheses. Okay, so at that point, I can hit what graph? And y'all, if you look at that, our graph is pretty dang close to that one. Also, let me show y'all another way to put this in. If you want it to look exactly like the problem they gave me, let me clear that. Hit the alpha button and then the y equals, and we want n over d, which is numerator over denominator. I hit enter on that. You can put the 5. Then you can arrow down and put your x squared minus 4. And it looks exactly like the problem. So either way works on that, okay? Notice when I hit enter, I still get the same graph.
Can you show that again?
Okay, so on the calculator, on how I did the,
Yeah, because yeah, it was so glitchy. I didn't see it.
okay. So doing it as a fraction.
Yes.
Okay. So first thing you want to do is hit alpha and then y equals. And that's going to pull up a little box. ND means numerator over denominator, which is what we want for a fraction. So I would hit enter. And it actually pops up as a fraction now. So on top of that, I had my 5. And then I just arrowed down to get to that bottom. And then on the bottom, I put in my x, and then I squared it. And then I did what? A minus 4. So now that I got it in, it looks exactly like the problem when you use that alpha y. The other way, you have to use parentheses to tell it what your numerators and denominators are. All right, so we hit enter, and we got our graph. Now, if you wanted to look at the table, remember I had vertical asymptotes at the 2 and -2. So if you come in here at -2, you get an error because that means it's undefined. And then we go to +2 down here. Whoops, went too far. We get an error because it's undefined there. So them calculators, they do quite a bit if you sort of know where it's all at, right? All righty, let me get these back. All right, so now we're going to go back to just finding vertical asymptotes. I think we did a few of these the other day. All right, so we're given on this one, f of x equals 1 over x minus 1 squared. All right, so vertical asymptotes was always take the bottom, set it equal to 0. So I'm going to bring down that x minus 1 squared, set it equal to 0. And then remember that 2 is telling me that this factor happens twice, because remember that's the multiplicity. So I'm going to write it twice since I'm solving it. All right, y'all, and at this point, since I got repeating factors, no matter which one I solve, I'm actually going to get the same answer. So I'm going to set my x minus 1 equal to 0, solve that by adding 1. So I get x is a positive 1. Now, the reason we only got one vertical asymptote on this is because remember, that's a even multiplicity, and even multiplicities come down and touch the line, they're tangent to it, but they don't pass all the way through it. So since it don't pass through, it don't go through and then have another 0, okay? So the final answer on that is x equals 1. So if you got a repeating factor, you only got to list it once as an asymptote.
So if you have y, it's going to be because it's an odd number.
Because the
Is
odd
that what
numbers
you
would
were
pass
saying?
through it.
Yeah.
Yep, they would pass all the way through, and then they have to come back up, so you would actually get both of the vertical asymptotes, right? To where if it's
Okay.
tangent, it never passes through the line. It just sort of comes down and touches it, so you just got the 1. So that's good thinking on that, right? All right, let's see. We're going to have an x minus 2 on top over x squared plus 6 x. So remember, I'm going to set that bottom equal to 0. So x squared plus 6x equals 0. And remember, this is quadratic again because I got an x squared in it, so I'm going to use the quad. So I'll tell y'all, A is 1, but let's see what y'all can give me for B and C. So y'all, this one, B, would be 6 because it's by the x.
6.
And then the C would be the 0 this time because you don't have a number at the end.
Yeah.
Okay, so notice the difference. Well ago I didn't have the x, so that number was my C, but this time I do have the x, so that number is my B. So if you use a quad, that would give you two answers. It would give you x equals 0. It would give you x equals a -6. And just to check, notice the top you got what, a x minus 2? If you set that equal to 0, you would get a 2 out of that, and 2 does not cancel the -6 or the 0, so I get to keep both of these answers. Now y'all remember on these, when you push these answers into MATLAB, you actually got to put the x's on them, okay? All right, y'all. F of x equals x squared plus 5x minus 14 over x squared minus 2x minus 8. Now this one, since that top is in a trinomial form, I'm going to quad that because I'm going to quad that to make sure none of those factors cancel with my bottoms. So the first thing is to worry about the bottom. So set that equal to 0. And this one, I'm definitely going to use the quad. A will be 1, B will be -2, and C would be a -8. If you punch that in on the quad, it would give you two answers. It would give you x is a +4, x is a -2. But y'all, I would probably quad that top real quick to see what kind of answers it gave you. So A would be 1, B would be 5, C would be a -14. If you quadded that, you would get x is a -7, x is a +2. So since neither one of them numbers match either one of my bottom factors, I can keep both of these asymptotes. Okay, so that's the main thing you got to do is just check that top. See, when I did domains, I didn't have to check the top. But when I look at asymptotes, I do got to look at the top to make sure nothing cancels on those. Now,
So if that +2 for the top had been a -2, that would have canceled out.
yeah, I would have canceled out that factor on top with the one on the bottom, and then the x equals 4 would have been my only vertical asymptote.
Oh, okay, so the denominator answer is the only one that matters, though.
Right. It's the only
Okay.
one that's going to give me the asymptote still.
Okay.
What happens when the top one cancels with a bottom one, instead of making a vertical asymptote there, it makes what we call a hole in the graph. So if you've ever seen graphs that were going along and then they had a little hole in them and then they started again,
Yeah.
that's because asymptotes canceled with that top zeros, okay?
Okay.
So here we go. I got a g of x equals x to the third on top over 5x to the third minus x squared minus 6x. So if you notice, this one's got a x to the third in the bottom. That means I could possibly have 3 vertical asymptotes. So what we got to do is start out by setting all that equal to the 0. Now at the moment, I can't use my quadratic formula because I got an x3 here. So what we want to do is factor out one of these x's so that we can get this to be a quadratic. And they all have an x in them, so we're going to factor out an x like a GCF. So what goes into parentheses, you take all three of these and divide out an x. So 5x to the third divided by x leaves you a 5x squared minus x squared divided by x would leave you an x minus 6x divided by x would leave me a 6. So that's going to be one of my answers in a second. But now to get the other two, I'm going to quad what's left in the parentheses. A will be 5, B will be -1, C will be -6. So remember, quad will give me the last two answers. That x will give me the third one. So what you would do is this x automatically, since it's a GCF, it's going to come down and equal 0. Because it don't have a number to go with it to solve. And then let's find those other two using the quad. So program, let me get down to quad. And enter and enter. So we had a 5, -1, and a -6. When I hit enter, I don't want that 1.2, so I'm going to hit enter one more time, and I get what? A x equals a 6/5, and x equals a -1. So far I've got 3 possible vertical asymptotes, but notice on top I got a variable, so I'm going to have to set it equal to 0 real quick and see what answer that gives me. Well, y'all, there's only one number in this world that I can cube and get a 0, and that would be a 0. So now I do have a factor on top that matches one of my factors on bottom, so we got to cancel them out. So that my only vertical asymptotes are the x equals 6/5 and the x equals -1. Okay, so did that make sense on how they cancel?
Yes, that makes
Yeah, I got
sense.
another question.
Uh-huh.
So if it was a one variable by itself at the top, do you still have to do anything to it?
What do you mean, like one variable, not just an x on top?
Yeah, if it was just like a x on top or like a 3x, do you have to do anything to that?
Well, that 3x, that x still would have canceled with the x on the bottom. Because if you set 3x
Okay.
equal to 0 and you divided them both by that, you would still get what, a 0 there? And since you still get a 0,
Yeah.
you have to cancel it with that one on the bottom.
Okay, and if it's an x by itself,
Excuse me?
and if it was an x by itself,
Yeah.
okay.
As long as that x would have been in every one of these terms, it would have basically canceled out.
Okay.
Okay. All right, so let's do some more practice on finding the horizontal asymptote. So horizontals, they can be the same. Top can be greater or the bottom can be greater. So for my first one here, I got f of x equals 7x to the 5th minus 4x over 3x squared minus 2x plus 1. So on horizontals, all we're looking at are the degrees. So my top degree versus my bottom degree. So the top, your degree is a 5. Bottom, the degree is a 2. So since the top is greater than the bottom, this one has no horizontal asymptote. Which means this one would keep trying to go towards that positive infinity or negative infinity. All righty, so f of x equals, for our next one, let's do a 5x squared plus 3x minus 4 over 7x squared minus 5x. So once again, we're going to compare the top degree and the bottom degree. So y'all, let's see, on this one, I got a 2 for the top degree. I also got a 2 for the bottom degree. So those are equal. So remember, since they're equal, it's going to be the ratio of A over B, where A was the lead coefficient on top, which was the 5. B is the lead coefficient on bottom, which is the 7. So your final answer would be y equals 5 over 7. All right, let me see, I got another one coming in. All right, I'm gonna let y'all write that for a second, then we'll do a graph and move on out of this chapter eventually. All right, so flipping. All right, so this problem's like the ultimate thing they wanted us to get out of this. So let's find it. We're going to list the domain. So list the domain. We're going to find the x and y intercepts. The vertical and horizontal asymptotes. And then graph. So they're giving us f of x equals x plus 7 over x squared minus 49. Okay, so I'm going to find that domain first. So to find the domain, I take the bottom, x squared minus 49, and set it equal to 0. So I'll quad that real quick. A is 1, B is 0, and C is negative 49. So this time we were missing the x term, so that gave me a B for 0. If you quad that, you get x equals 7, x equals negative 7. So in the domain, I got to take out all these answers. So my domain starts at negative infinity until I hit negative 7. Then I union around negative 7 until I hit positive 7. Then I union around positive 7 until I hit positive infinity. So when you got two x's in that denominator, you got to exclude both of them from the domain. All right, so that's what MATLAB wanted. Now it says x and y intercepts. So to find x-intercepts, I would set the top equal to 0. So I'm going to set x plus 7 equal to 0. So we'll solve that by subtracting 7. So y'all, that gives me x equals a negative 7. Uh-oh, what happened though? Y'all see that? I got a negative 7 on top, right? I also
Because
had
it's
I had a -7 on the bottom, right?
right.
So since that top matches that bottom, that x-intercept cancels with
Cancel
this vertical asymptote.
Cancels out.
Yes, it's going to cancel that vertical asymptote. So since we canceled that x-intercept, there is no x-intercept. So it will not cross over that x-axis anywhere. So now we got to find our y-intercept. With a y-intercept, I had to find f of 0. So we would put a 0 in for the x's. So I get 0 plus 7 over 0 squared minus 49. All right, so let's see. That'll give me a 7 on top. 0 squared is 0. 0 minus 49 will be a minus 49. So that'll reduce to a negative 1 over 7. So that means your y-intercept is at 0, -1/7. All right, vertical asymptotes. Well, we already solved the bottom when we solved it for the domain, and we already canceled out the factor with the top that needed canceling. So the only vertical asymptote on this problem will be x equals 7. All right, then we look at the horizontal asymptote. Horizontal asymptote, the degree of the top versus the degree of the bottom. So let's see, on top, since there's no exponent there, that is a 1. So the top had a 1 degree. The bottom, let's see, had what, a 2 sitting there. So this time the top is less than the bottom. Anytime the bottom was bigger than the top, it was y equals 0. Alrighty, so we should have enough to get an idea of this graph. Now remember, I might have to find another function value or two just to tell me if something's positive or not, but we'll see. All right, so I'm gonna move that over and put my paper up and draw this graph again. I'm just looking to see how they did their table on it real quick. All right, so when we graph it, I'm going to set it up as 2 and 10s on it, okay? All righty. All righty, so let me go out 10 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'll do a -10. And then 1, 2, 3, 4, 5, 6, 7. I'll do 10 up and 10 down. All righty, so we only had one vertical asymptote to draw, and that was at x equals 7. So over here at 7, 1, 2, 3, 4, 5, 6, 7, I'm going to draw a dotted line. All right, so we cannot cross that line. We know eventually the horizontals are going to be trying to get to the 0 on the x-axis. There's no x-intercept, so it cannot cross the x-axis. The y-intercept was 0, -1/7. Woo, -1/7 is barely on the other side of that 0, but we know it's negative, okay? Now, where they cancel that at this -7 is really 1, 2, 3, 4, 5, That -7 would be like a hole in our graph. All right, so since it cannot cross the x-axis, the only way this can go here is down. Now this side's going to come along. It's going to go where the hole is, and then it sort of comes up and then levels back out trying to get to the 0. So y'all, what we need to figure out is this side going to be positive or negative? So since 10's on that side, I'm just going to find f of 10 real quick to see if it's positive or negative. I don't really care about the number. So that would be 10 plus 7 over 10 squared minus 49. So I get a 17 on top. That's what? 100 minus 49. So what's that give me? 17 over 51. Oh, and y'all, that will reduce to a 1/3. But I don't care about the number. I just wanted to see that it was positive. Since it's positive, this side has to come down from here. Remember, it cannot cross the x-axis, and it's just going to keep trying to get to the 0. So those would be your horizontal asymptotes as they go out. So let me show you how to draw that real quick so we can see if we are sort of close on that. So y equals, I'm going to clear that. If you do it the parenthesis way, you would do parentheses x plus 7, close parentheses, divided by parentheses x squared minus 49, close parentheses. And then we would hit enter to draw this. So there's our side. So y'all, it's so close. So on the answers, they had the y's going from 2 to -2. So I'm going to show you how to set the y's. Hit that window button and go down here to the y minimum. Instead of the y minimum being -10, I'm going to make it a -2. And then the y max, I'm going to make a +2. So now my graph is like they got in the answers, a -10 to a 10, and then a -2 to 2 on the x's. Watch how it changes the graph to where you can see it better. And there you go. So, woo, they tricky, but y'all see there's our vertical asymptote coming right down through there, okay? All right, y'all, so now we're out of this chapter here. So let's go into 8.6. And y'all, 8.6 is the last section in this third test material.
All right, so after this, we'll have a test.
Yeah, so what I'm planning on doing, and I got study guides already set up on the MATLAB, test 3 review. So what we'll do, we'll finish today. Tuesday, we will review for the test. And then y'all gonna be ready for it. And then y'all just take it anytime before I think that next Sunday I said. And then that way we'll just keep moving on with new material that next Thursday. So this was going to be your take-home test anyway, so thank God it's already take-home, right? So polynomial inequalities. So you got to refresh yourself. So recall, because I'm going to be writing my answers in interval notation. So if it's greater than or equal or less than or equal, I got to use brackets for my answers, right? If it was greater than or less than, we had to use the curvy parentheses. Okay? So, the steps to solving. You're going to get everything on one side equal to 0. At that point, you want to solve your polynomial. So use the quad formula to solve. Then we're going to set up a test interval using the solutions. So that's going to be something like this. I'll have two answers, a A and a B. I find the test number. If true, shade that area. If false, shade elsewhere. So y'all, the two type of answers you can get on this when you got two solutions is it's either going to shade in between. If it shades in between, your answers will be from A to B and be done. If it shades on the edges, so if you got two solutions, it's got to be one of these two styles. But if it shades on the edges, those are going to go from negative infinity to the number, and in union, the second number to positive infinity. Okay, so once we did our test, right answer in interval notation. Now, if you do not get rational numbers as solutions, then you get what we call no solution. So that just means you got an empty set that it didn't have no answers, okay? Also, if you only get one solution, then that is the only number excluded. Okay, so you got to watch for these special cases down here. If you cannot factor it, it's no solution and you're done. If you only get one solution, then your interval will go from negative infinity to that number, union that number to positive infinity. All right, so I'm going to give you all a second to write those, and then we're going to solve. And these ain't bad. There's only like 6 or 7 of these, I think. And you can quad every one of these but the first one. The first one you don't have to quad because it was already sort of solved. So y'all, I'm going to turn over and we're going to solve these. We're going to solve and write in interval notation. So my first one, I got an x minus 3 times a x plus 4 is less than 0. And I'll show you what these answers do on these calculators also. Now, since this one's already factored and I got a 0 over here, all you got to do is set the factors equal to 0 and solve them. So here I would add 3. So one answer is x equals 3. Second one, I would what? Minus 4. And I get x equals a negative 4. So I got my two numbers. So now let's make our test interval. Negative 4 comes first, and then the 3. Now, the only number I pick for my testing is 0 because, y'all, 0 is the easiest number to multiply, add to, or anything. So I'm going to test 0, and I know 0 would go in between these two numbers because that's a negative and that's a positive. So when I test 0, if it's true, I'm going to shade where the 0 was. If it's false, I can't shade where the 0 was, so I got to shade the two outsides. Okay? So let's see what happens when we test a 0. 0 minus 3, 0 plus 4 has to be less than 0. So that's a negative 3 times a positive 4 has to be less than 0. So I get negative 12 less than 0. That is true. So since that's true, I'm just going to draw my line again so y'all can follow me. So since that's true and 0 was in the middle, I'm going to shade the middle part of this interval. Now, write answer in interval notation. Well, remember, when we shaded the middle, it went from that number to that number, and that less than does not have equals under it, so these will be in parentheses. So parentheses negative 4 to positive 3, and then close parentheses. So, y'all, they're not too bad. You just got to get those answers so you can set up that little interval, and then always test 0. 0 might be here. 0 could be there, or 0 could be in the last section. But when you test it, it'll either be true or false on those, okay? All right, so moving on. All right, y'all, same thing. I got an x squared minus 13x plus 22 greater than 0. So I'm gonna hit that with the quad. A equals 1, B equals negative 13, C equals 22. If you quad that, you would get a positive 11 and a positive 2. So then let me make up my interval. Oh, but remember, 2 is over here, and 11 would technically be way up there. So this time when I test 0, notice 0 is in the very first section. So if it's true, I got to shade the first section and the last section. If it's false, I'm only going to shade the middle section. So let's put a 0 into our equation. So I got 0 squared minus 13 times 0 plus 22 has to be greater than 0. So now you see why I like 0, because that's gone. That's gone. So basically, 22 greater than 0, true or false? That is definitely true. So let me draw my interval. So it was true, so we got to shade where that 0 was. Skip the section in the middle and then shade to the other side. All right, interval notation. There's no equals on this, so I'm going to still use parentheses. But y'all, this time it comes in from negative infinity until we hit our 2. And then with union, we skip everything in the middle and we pick up again at a positive 11 until we hit positive infinity. Okay, so the trick on those is just coming up with those intervals and making sure you're testing those zones to see where it's going to be true or false. Now I'll show you something that's cool on those. If you was to graph those, so let me go to y equals. Clear that. I'm going to put in the x squared. What's that? Minus 13x plus 22. And I'm just going to graph it. But first, remember, I'm going to put my window back on standard by hitting zoom, number 6 for standard. I'm going to put it back on a 10 by 10. Now you see it's coming up on that other side. So my window's a little bit short. So if I want it to match this graph, I got to get bigger than that 11. So let me make my X max, how about 12? And then hit that graph. So since ours was greater than, the part of the graph that's above the line is what's greater than. So notice it comes in until it hits that 2, it's above the line. Then from 2 to 11, it's below. But at 11 here, as you go to infinity, it's above the line. So the graphs can be used also to sort of help you decide on those, okay? All righty, y'all, let's see what we got here. X squared minus 4x minus 22 is greater than or equal to an x minus 8. So the first thing we need on this one is a 0 where these two things are at. So that means I need to move to x by subtracting.
I've got a quick question.
Okay, I got you.
On just the last problem we did, how come you shaded outside instead of inside?
Because see, since 0 come before 2 this time, I knew 0 was in this section over here, right?
Uh-huh.
So when I tested 0 in that section, it gave me a true response.
Uh-huh.
So since it's true, you actually got to shade where the 0 was. And remember on that first, when I was giving you the rules, if this side shades, automatically the other side is going to shade.
Oh, okay. So you pretty much shade the location where the 0 was at.
Uh-huh. Now, had that
Okay,
been...
gotcha.
But now listen, had that been false, I would not have shaded that 0's area. I would have only shaded the middle area. So true, I shaded where the 0 was. False, I do not shade where that 0 was, okay? So you just got
Oh, okay.
Now, what's nice is...
So you're only shading where the 0 is.
Well, I shaded the other side and the 0 wasn't there, right? So remember, they're either both going to shade...
Right.
It's either going to shade both outside edges or it's only going to shade that middle, okay? But it does not shade the whole line.
Okay.
And then you can't have 2 sections in a row that are not shaded or 2 sections in a row that are shaded, okay? All right, so let's see. We're going to subtract x's, and we're also going to add 8 to both sides and see what we get. So the x squared comes down. -4, -1, give you -5x. -22 plus 8 is a -14, greater than or equal to 0. So we can quad that. A is 1, B is -5, C is -14. If you quad that, you get 2 answers. You would get x is a +7, x is a -2. So I'm going to come up here and draw my line. So notice I got a -2 here and a 7. So this time the 0 would actually be in the middle section. Would y'all agree?
I agree.
Because there's -2 and that's +7. So 0's there. So they're going to test our 0 now. So to test my 0, I'm actually going to use this equation where we got everything on one side. So I got 0 squared minus 5 times 0 minus 14 has to be greater than or equal to 0. Well, let's see, that cancels, that cancels. So the question of the day, is negative 14 greater than or equal to 0? True or false?
It is negative 14 is false.
That's false. So since that's false, we cannot shade where the 0 was, okay?
So we'll be shading outside.
So we'll be shading outside because I cannot shade that middle where the 0 was, so I gotta shade my outsides, okay?
Gotcha.
Now, that means this interval is coming in from negative infinity over here. It's going until we hit negative 2. Now, you got equals in this problem up there because it says greater than or equal, so that means you gotta use a square bracket.
The brackets.
There you go. And then union that a bracket, we don't have nothing in the middle shaded, but we did shade from the 7 to the positive infinity. Okay, so if you did each of these numbers, any number on this side would make it true. Any number in the middle would make that a false equation. But any number 7 or bigger would make that true again. Okay? But it's just so much trouble trying to go through and test 3 or 4 numbers when we can just use a 0 and look at the patterns on them, okay? All right, y'all, so I'm flipping over. Y'all got that?
Can you pull it up some?
I'll pull it up like that.
Yeah, just a little bit.
Okay.
Okay. Okay, I'm done. Thank you.
All righty, next one. 81 minus x squared less than or equal to 0. So I'll tell you what I would do on that, and I would probably rearrange that and get it in the right order. So I'm going to put the negative x squared plus the 81 less than or equal to 0. And then I'm going to quad that. A is negative 1, B is 0, and C is a positive 81. If you quad that, you get x is a negative 9. You would get x is a positive 9. So we'll set up my interval. So let's see, negative 9 would be over here. Positive 9 would be in the middle, on the right side. So that means 0 is going to be in between them two negative numbers somewhere. So I know my 0 is going to be in the middle. So once again, true, I shade the middle. False, I trade the outsides. All right, now what's nice is you can use either equation to check it. So I'm just going to use that top one. 81 minus 0 squared has to be less than or equal to 0. 81 minus 0 is 81. So 81 less than or equal to 0 is definitely false, right? So let's draw our interval. Negative 9, 9. So since 0 was in the middle and false, I cannot shade that. So once again, I got to shade the outside edges. All right, I do got equals on that, so I will use the brackets. So I'm going to come in from negative infinity till I hit my negative 9, union, and remember that is a bracket, and then bracket from a positive 9 to positive infinity. So really the only thing new on y'all on this is coming up with these number lines and testing them to see where those intervals are going to be, okay? Oh, y'all look at this, and it's all mixed up. You got a 2x minus 1 minus the x squared less than 0. I'm definitely going to rearrange that. So I'm going to get the negative x squared plus the 2x minus the 1 less than 0. I'm now going to use the quad. A would be negative 1. B would be 2. C would be negative 1. If I quad that, look what it gives me. It gives me a x equals 1, x equals 1. That's a repeating answer. So on your interval, you've only got the one number there. So we can only exclude that one number. So if you remember my second star, if you only had one answer, you only exclude it. So that means it goes from negative infinity to the 1. Then you union the 1 to the positive infinity. And then remember, the only reason we got one answer is because that's where that comes down in its tangent, right? Since you got repeating factors, multiplicity 2, it just sort of comes down and touches and then it's gone. It's equal at that part, but we didn't have an equal sign under here. We just had a less than sign, okay? All right, y'all, I got one more special one, and then that looks like it for today. So I'm gonna pull this one. So our last one is going to be x squared plus 16 is less than 6x. So once again, I need to get a 0 there. So I'm going to subtract the 6x from both sides. So that's going to put it in the middle over here. So I get an x squared minus 6x plus 16 is now less than 0. All right, so if I quad that, 1, negative 6, positive 16. So let's see what that's going to give us. So enter. Clear that, quit that, clear. Ooh, all that button, right? All right, program, go to quad. Enter, enter. So I had a 1, negative 6, positive 16. Oh, I'm getting imaginary answers, which means this does not factor as a rational number. And y'all check this out. There's no factors of 16 that add to get a 6, right? 4 and 4 add to get 8. 2 and 8 add to get 10. 16 and 1 add to get 17. There's no factors of 16 that'll give me a 6. So this does not factor, which means it has no solution. Now in MATLAB, since it's no solution, they have what you call the empty set. It looks like a 0 with a line through it. Alrighty, so that is it for today. So I'm going to stop the share so I can turn the video off. And then stop.